So this is the fourth question of the 2016 March calculator paper, and I'm going to be doing the question sequences. So I've already defined this function in my calculator on a graph doing menu 3 then 7 for the sequences, and defined it. Now I have to define it in a slightly different way by doing u1n and then u1n minus 1. Anyway, I get the numbers I'm looking for is u2 is equal to 2.5, u3 is equal to 3.2, u5 is equal to 4.1639 to 4 dp, and u8 is equal to 4.4015 to 4 dp. I'll post a separate video to show you how to do this on the calculator, just in case you're unsure how that works. And that was for 4 nice marks there. So moving on to part B, sketch and hence describe this sequence. Now unfortunately I'm not too good at drawing straight lines on this, but I'll try my best. Again, I think the easiest way of doing this is I'll do it on the a separate. It's doing something like, so it's something like this. Okay. So it's converging sequence. Okay. And I reckon if I'm using my table of values, it looks like it's converging to 4.41 something. So look at this. We know it's converging. It says it's converging. So I can do the following. I can say that when it converges, un plus 1 is equal to un. So we take the sequence, and I just say, so the sequence is un is equal to 6 minus, just double check I get this absolutely right, 6 minus 7 over un. I multiply by 3 through un, so I get, sorry, I'm just going to minus 6 un plus 7 equals 0, and I can solve for that using the calculator. So I'm going to solve this as if it was some sort of quadratic, which it kind of is. And I get a value that un is exactly what I want it to be, 4.1421. The other value, because it's, I should have said it's an increasing, I forgot to say it was increasing in part B, but because it's increasing, we know it has to take the value of 4.1421 rather than the 1.58, which is the other answer it gives. So another sequence for part D is given by this. Now this is it's obviously an explicit sequence. Okay, to determine if the sequence increases or decreases, use an appropriate method. So let's do a bit of differentiation on it. So we're going to say, we'll call an, we'll say it's something like f of x. So we have f of x is equal to 0.8 x squared plus 5 over 2x squared. So I'm going to differentiate that using the calculator. And to get my answer, that derivative is equal to minus 5 over x cubed. So the gradient is negative. So we have, so if the gradient is negative, it's a decreasing function when x is greater than 1. But don't forget, we can say it's the same thing for being n. We can also sketch that function, and if we put that function as a graph, we can clearly see it's doing something like that. Calculate the limit of this sequence, which is, so that was part D, sorry, this is part E. Calculating the limit of the sequence, we can just do lim of f of x as x tends to infinity. So what we can do is do the derivative of it is 1.6 x over 4x. Do the derivative again, 1.6 over 4. So 1.6 divided by 4, nice and easy, is equal to 0.4. And that is for our 2 marks. And that's it done.